Hello everyone, welcome back to another GIS statistics lecture video. And in this lecture video, I want to talk about something called linear interpolation. After nearest neighbor, which doesn't really do any sort of hard conceptual calculations, linear interpolation actually changes or estimates new values. So nearest neighbor, we were just kind of taking existing values based on your closest point. With linear interpolation, what we're doing is we're calculating a new value that is in between existing values. So what I want to do is I want to walk through sort of conceptually what linear interpolation looks like, walk through the equation, and then in the next video I want to walk through an example looking at the idea of contours, which is one of the ideas where linear interpolation gets used most often. So let's talk about what linear interpolation actually looks like. So let's assume that we have a point here called A, right? And we have a point here called B, right? What linear interpolation can do is, assuming that our point lies on a straight line between A and B, let's say it lies right here, and we'll call this C, right? Linear interpolation will allow us to use the value of A and the value of B to estimate the value of C. Or, given A and B, given the value of A and the location of A, the value of B and the location of B, we can estimate where along this line some new point C will sit with a given value. And I know that probably seems a little confusing, but as we go through the equations, and then in the next example, in the example video, in the next video, hopefully that will make a lot more sense what I mean by that. But for now, let's just go ahead with this diagram here. We have A and B, and we have some unknown point here that we're going to call C. And we want to know what is the value, right? What is the value at point C? The value at... Let me clean that up just a little bit. We want to know what the value is at point C. So something that we know is the value and location of A and the value and location at B. Let's actually write that down. Right, we know the value and location of A and the value and location of B. Right, those are two things we know. These are known points. So all we have to do to figure out the value at C is to say, okay, we know, and I'm going to use the Z here for the value of A minus the value of B. Right, so this is the difference in value over the distance. I'm going to use distance of A to B. Right, this ratio in the difference in value over the distance between those points is going to be the same as the ratio of Z at C, which we don't know, minus Z at B, which we do know, over the distance between C and B. And this should also be the same as the distance is the value of A minus the value of C over the distance between A and C. So basically what I'm saying is the ratio between the difference in value from A and B relative to their distance should be the same as the difference in value between A and C relative to their distance, and the difference in value of the ratio between the difference in value of C and B relative to their distance, right? That's what this is saying. So hopefully that makes sense. Oh, I suppose we should also say we know the location of B. We know the location of C as well. But we don't know this value here. We don't know ZC. So what we can do here, if we give ourselves a little more room, is we can take this first equation here, right? ZA minus ZB, which we know, divided by the distance between A and B, which we know, equals, let's go ahead and take let's do this equation over here, ZA, which we know. I'm going to replace, well, actually, we'll keep ZC, which is what we don't know, right? This is our unknown. We don't know that. But we do know the distance between A and C. So we know all of these things. So now all we have to do here is some quick algebraic manipulation to solve this unknown. Right, so all we have to do here is we have to solve, so first we're going to multiply it by the distance AC. So we'll do, I'm going to abbreviate here, right, DAC. So this is, DAC is the distance between A and C times the value at A minus the value at B divided by the distance between A and B. Right, again, I'm just abbreviating dist with D so that the equation doesn't get too cluttered. Equals ZA minus ZC. Again, these are just the values. This is the value of A. This is the value of C. Now we add ZA to both sides. Again, we subtract ZA from both sides. Again, I'm just doing basic algebra here. Right, so we have negative ZA plus, and then D, distance between A and C, times A minus B times ZA minus ZB, right? These are the values, divided by the distance between A and B, is equal to negative ZC. So now we just multiply through by -1. So I'm going to rearrange the equation here. We get ZC, right? This is the thing we wanted to know. This is the value at that new point. Is going to be equal to ZA minus, again, because we're distributing the negative, distance between A and C times ZA minus ZB divided by the distance between A and B. So hopefully this makes sense. So this would give us the value of a point given its location and the location and value of 2 points that all form a straight line. Hopefully that makes sense. I know this was a lot of basic algebra here. In the next video, we're going to go through an actual example of this linear interpolation. So if any of this was confusing, I encourage you to pause the video, go back, rewatch the part you're confused about, and as always, please reach out. Thank you.